Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. So today we are going to look at the concepts of gamma emission and internal conversion. So this is going to be an additional concept from the radioactive decay processes that we have exclusively looked at from our previous videos. So in this particular case, we are going to look at a process which is going to proceed the particular decay processes which we had mentioned earlier for gamma and beta decay. And of course, we're going to see that after the processes of alpha and beta decay, of course, we're going to see that the daughter nucleus are going to be left in some kind of an excited state. So for instance, if we try to compare this to be a radioactive decay process of transitioning from the radioisotope X to a nucleus or a nuclide Y in this specific case, and then there is an involvement of the alpha particle. So this is an hypothetical example I'm just trying to give for illustration purpose. So it is transitioning to this specific state of a daughter nuclide, which is Y and Z. So we're going to have this one being illustrated as such. And of course, if we try to compare this as the variable for energy, then therefore we're going to see that this specific point is going to be at a higher energy state, perhaps over E3. And we can be able to compare in this specific state for E2 and E1 respectively. We can be able to allocate the last part of this at E0 or E0 to denote the ground state for this specific radio decay isotope. So in this particular case, when we will find that this particular isotope has undergone radioactive process and released the alpha and the beta particles to produce these daughter nuclides. We are going to see that still these are going to be remaining in an excited state. So they have to go back to the ground state in order to attain what we refer to as stability. And this is going to involve the release of energy in a process that is referred to as internal conversion. And this energy is going to be in form of the gamma rays. So we're going to have the gamma rays being released from this particular daughter nuclide to the last stage in order to attain what we call stability from this particular excited state. So these are going to be excited state of the daughter nuclides. So therefore, they are going to release energy in terms of gamma rays in order to attain a stability. So this particular type of rays can be, of course, detected since they have a characteristic of being fluorescent. And in this case, of course, they are going to produce what we call scintillations. So we're going to learn about these specific terminologies whenever we're trying to talk about the concept of measurement of radiations, etc. So they're going to produce what we call scintillations with what we refer to as phosphor. So this basically phosphor. So this basically is what we call a flash of light. So phosphor. So that's correctly spelled. So this is going to be producing scintillations, which are basically a flash of light that are being produced by this specific substance, and therefore they are going to be involved in this specific process of fluorescence. And this is going to assist us, of course, determine this, of course, the release of this particular kind of energy in form of gamma radiation. So therefore, this is one of the ways in which you can be able to determine a daughter nuclei which is undergoing this process of internal conversion by exposing them to this particular type of materials. And this basically we can be able to give an example of a compound like sodium iodide, which is going to fall under that specific class. So sometimes we're going to see that we have talked about the concept of a half-life. We're going to see that this process of internal conversion may occur immediately after these two specific processes of alpha and beta decay have occurred, or sometimes it may take a long time depending on the kind of a radioactive isotope that is going to be, of course, involved. So in this case, we're going to see that some highly excited nuclei that are going to be involved for this specific case, for instance, for Y and Z daughter nucleus, are going to be referred to as isomers. So in this case, if we have a highly excited nucleus that is going to be in this specific state, we're going to be referring to them as isomers. So we have come across this specific term, especially in a discussion on various topics in organic chemistry. And in this case, if we mention the term isomers insofar as gamma emission and internal conversion in that specific context, then we're going to refer to as highly excited and daughter nuclei, which we have given as such. We can be able to give an example of this nucleus, which are going to be, of course, falling under this category of isomers. We have, for instance, the cobalt 60, which of course is going to transition to the cobalt 60, of course, from this excited state, and this is going to, of course, undergo the release of a gamma ray in order to form what we call the stable state, this ground state. So this is going to involve a transition from the excited state to the ground state, and this is going to be a process that we refer to as internal conversion. So we can be able to detect this specific process by subjecting this particular radiation to compounds which we have said, which are going to display the aspect of scintillations as I've mentioned. So this decay process that we have, of course, mentioned in this particular case, whereby they are going to involve these isomers. As we can see, these are basically the same element, but it's going to be undergoing transition to form a stable one. So this particular process is referred to as isometric transition. And of course, we're going to see that in some cases, we're going to see that the excitation energy that is being involved in this particular case is going to be directly transferred to the nucleus of the orbital electrons of a particular isotope, radioactive isotope that we are mentioning. So without involvement of particularly the release of this gamma ray, as I've mentioned. In this particular case, if there is no release of this gamma rays, but transfer of this energy to the orbital electrons, there's going to be a different term that we're going to refer to this. And of course, this is the basic term that we had mentioned earlier in our discussion, which we had referred to as the concept of internal conversion. So basically, this is going to be the transfer of energy from the nucleus to the orbital electrons, as we have said, and basically this is going to involve the concept of internal conversion. So we can be able to differentiate between this aspect of a gamma emission, whereby there's going to be a release of this gamma ray, and then internal conversion is a transfer of energy from the nucleus to the orbital electrons, which are going to be involved in this particular radioisotope under consideration. So I hope that we have understood this, the distinction between these two specific aspects of gamma emission and the internal conversion. And basically the concept of gamma emission is to bring a radioactive isotope or a daughter nuclide from the excited state to the ground state through the release of energy. And the internal conversion is whereby the nucleus, the excitation energy in the nucleus is transferred to the orbital electrons, of course, of that daughter nuclide, as we have said. And the transition, which is going to involve an radioactive isotope that is going to be, of course, of a highly excited state to a ground state, like this one that I've given for cobalt 60, of course, is going to be referred to as isometric transition. And this is such a kind of course, daughter nuclides are referred to as isomers, as I've mentioned. So this, together with other illustrations, are going to assist us interpret the concept of radioactive decay. And I'm going to put a link of other videos in our description box so that it can assist us, of course, understand the various aspects that we have discussed insofar as radioactivity is concerned. So that is it for now, guys. Bye. God bless you.